This is the fourth episode of the series on Spring Boot development in Kotlin. In this video, we are going to write a REST controller that reads and writes to a MySQL database using Spring Data JPA. We are using Liquibase for database migrations. The source code is in the video description as always. We are going to start by creating the project using the Spring Initializer. So we search for Spring Initializer. And in here, we select Gradle project, Kotlin. This version is good. We are going to call it boot4. And as dependencies, we are going to add dev tools for hot swapping as usual. We discussed it in the first video of the series. Then we need to add Spring Web because we are writing a REST controller. Then we are going to add JPA for the Spring Data. Then we need the MySQL driver, and there's another one. We need Liquibase for migrations, and yeah, just these 5 dependencies. We hit generate, and then extract that archive, and we open it in the IntelliJ Community Edition. I'm gonna skip ahead because IntelliJ takes a while to index. IntelliJ has finished indexing the project. The next thing that we need to do is create a database and configure the Spring Boot application. So in a terminal, I'm gonna connect to the MySQL instance running on my local host. I'm gonna use the root user. And in here, we're going to create a database. So this is the databases I already have. And I'm going to create a database called, let's say, JPA. And then we connect to it, connect to JPA, show tables, and there are no tables right now. And now in our Spring Boot application, we go to resources, application.properties, and we need to configure the Spring Data Source. So in Spring Data Source URL, this needs to be a JDBC URL. So it's going to be JDBC MySQL // localhost. Here, if it's running on a different port, you can specify it. We'll specify it anyway. It's the default port 3306. And then / the name of our database. Name of our database is JPA. Then we need to specify the driver class for the database we are using. So data source driver class name. And it's MySQL CJ, and then JDBC MySQL. Oh no, it's just a driver, I think. Yeah, driver. Then we need to specify the username and password. I think it's username. We're gonna use root, Spring Data Source, password. Here I recommend using environment variables for not writing passwords inside of properties files because you can accidentally commit them to GitHub or a Git repository. It's better just to keep them in environment variables. And we also need to initialize the database. So if we search for Spring Data database initialization, we'll see here that there are some default methods that Spring Data and JPA can use. There's these one, generate DDL, and there's one for hibernate. I think I used this one once, and I didn't like that it creates a lot of things automatically. I like to have more control over the database migrations, and that's why I prefer to use the migration tools. In this tutorial, we're going to use Liquibase for migration. So we need to turn on Liquibase, so it's Liquibase enabled true. And Liquibase also needs XML file, or I think it supports YAML as well, but we're going to use XML, where the database migrations are stored. So we need to provide the path to this file as well. Liquibase change log. So this path will be will be relative to the resources folder. So in here, I'm going to use db slash liquid. Actually, it already created a changelog directory in here, so we're going to put it there, changelog. Let's call it log.xml. So this should do, and now we need to create that log.xml file. So in here, log.xml, and we're going to search for the basic Liquibase XML file, Liquibase XML quick start. So yeah, just this header from here. We copy it and we close it here. So if this one is not used, we're not going to include it. And also these two, if they're not used, we can delete them if they're grayed out. Okay, so this looks good. And now we can try to start the application. We create a new, let's see, modify run configuration, because we need to add the database password environment variable. So db password. In my case, the password is empty, but if you have a password, you need to fill it in there. We hit apply, and now when we try to start it, it should hopefully work. Oh, I have another application running locally. It said port 8080 was already in use, but now hopefully it's fine. Yeah, it says here it started in 4.966 seconds. And if we look inside the database, what happened? So Liquibase created these two tables. This table, database change log, keeps track of what migrations have been applied. And database changelog lock, it's a locking mechanism that prevents two different servers from performing migrations at the same time. And in some cases, if you run into racing conditions with Liquibase, you will need to manually release this lock. Just keep that in mind. Next, we are going to create a table in a database and then an entity in our Spring Boot application that maps to it. So we're going to start in our Liquibase file, and here we are going to add a change set. So for change sets, we need ID, let's say ID 1. I number them 1, 2, 3, 4, 5, so on and so forth. And each change set needs an author. And then here we have different operations that can be part of a change set. We can create tables, modify tables, insert rows, etc. Here we are going to create a table. It's going to be called account. The first column will be ID. So we provide type integer and auto increment true, because this will be the primary key of the table. And now we're going to add constraints. Primary key equals true and nullable false. And this table will have just another column that will be called name. So the name of the second column will be name. Type, it'll just be varchar of 255. And again, constraints, nullable equals false. And yeah, this should be it. Other things, so this file, if you have a lot of changes, of course it can get pretty big, but then you can actually move these change sets to separate files and then include them in here. So you do include and the file where you have this change set, and yeah, you can organize the Liquibase code better that way. But for now, this is fine. And now if we just restart our application, and we see it started again. And if we do a show tables in our database, we see that the account table was already created, so this migration was executed. And if we look into the entries, we see that there is nothing right now. Next, we need to map this table to our entity in our code. So in here, we're going to create a new file. Let's call it account. So here we're going to create a data class account, and it will have two fields with the same names as the table. So there was ID of long and name of string. So in order for this data class to map to the database, we need to annotate. We need to use this annotation from Java persistence called entity. And by default, this annotation will look at the name of the class that it annotates, so and then it will map it to the table with the same name. If we want to map it to a different table, let's say we need to use this other annotation called table. So we import it, and name, so we can have something accounts to or whatever name, but for now we're just going to use the default one. And in here, for the ID fields, we need to add the annotation ID from Java persistence, and we need to mark it as a generated value and give it a default value of 0. And in here, in generated value, there are different Spring Data JPA has different strategies for generating IDs. And the problem is that the default strategy, which is strategy generation auto, it doesn't work with MySQL. And for MySQL, we need to use generation type identity. And what this strategy does is that it uses the auto increment that we set when we created the table. This is there are more efficient generation strategies. So the generation type auto is more efficient because JPA can apply some optimizations, but this one is pretty fast as well. And yeah, we'll have to use identity for now. We'll also create a repository for accounts. So we'll write an interface called account repository, and we are going to extend CRUD repository. So this takes two generic types. The first one is the type of the object that the repository applies to, and the second generic type is the ID type of these objects. So in our case, it will be the first type is account, and the second type is long because it's the type of this ID field in the entity. And next we can move on to creating the REST controller. So we're going to add a class called accounts controller, and it will take in the constructor the repository we just created. So this thing in here, and we will annotate it with REST controller and request the mapping accounts because all the endpoints will be under the accounts path. And first we are going to start with the endpoint that returns all the accounts in the table. And so all these endpoints in the REST controller, they need to return a type of object that will then be converted to JSON. And we could use this entity, but usually I prefer not to, because in some cases there might be fields in the entity that don't need to be returned to the API, and also it's not good passing these entities around, because once you have an entity, you can alter data in the database, and I just prefer to have this separation. So I will make another data class that I call view account and has the same two fields, ID of type long and name of type string. And then I'll also have a method that converts from account to view account, and we'll call it account. We'll call this method to view, and it'll just create a view account of ID and name. It is a bit redundant, but it feels safer having this separation between database and API response objects. And now we're just gonna have a method called find all, and it will return an iterable of view account. And we need to annotate it with get mapping. And in here, so if we look at the account repository that we just created, just by extending the CRUD repository, we see that we get a bunch of useful methods. So we have this find all method that returns all the entries in the table. Then we have find all by IDs, count. We can find a single account given an ID. We have a method that saves a new one or updates a new entity, etc. In our case, we will, for this endpoint, we need to call find all and then map all the entities to view. We apply the function to view that we just wrote that will convert them to this view account data class. So now if we just build the project, we will see that it updated, and now we can actually try it with using Postman. So it will be localhost 8080 accounts, a get method, and of course we see that it returns an empty list because there are no accounts at this moment. Now we can work on account creation endpoint. So in here we need to create a new data class that will be the JSON input for this method. So we're going to call it create account, and it will only have a name field because at creation time we don't have an ID. The system will assign it and then return it in the response. And here it will be, the function will be called create, and it will take this new data class that we just wrote. It's called create account, and here we need to annotate it with a request body annotation. And this will also be a post mapping method, and it will return a view account. So in here, in account repository, we need to save a new entity. So now we need to construct it. We need to construct one of these objects of the one annotated with entity from the create account. And ID, we can, if we leave it to 0, then we tell JPA that this is a new object, and it will assign an ID to it. So now we create an account data class in here, and name equals create account dot name. Let's see what the problem is. No, there's no problem. Okay. So now we just convert the object we received to view. So the save method will return an account entity, and we need to convert it to a view account because these are the response objects that we always return. And everything looks good. Let's try it out. Where is it? Build module, yeah. So yeah, if we, in here we can create a new path where we need to set it to post. So again, localhost 8080 accounts, And body, we need to select raw and JavaScript, or no, JSON. And in here, name, let's do first account. And we see it gave it ID 1. Let's do a few more. Account 2. And let's do third account as well. Like this. It looks like it's working. So now if we call the get all endpoint again, we will see all 3 objects that we just created. The CRUD repository interface we based our repository on has the basic methods for reading and writing objects, but it is very likely that we'll need to write custom queries for our code. And there are 2 methods in which we can do this in JPA. The first one is letting JPA actually derive the query from the method name. So what do I mean? In here, if we add a function called find by name starting with, and then we have in here, let's say, prefix of type string, and this one iterable, it will return an iterable of account. So JPA has this secret language, and as long as your method name is in a specific format, it will convert this to the correct SQL query. And we can see this syntax in here. So if we search for Spring Data query creation in here, and I think it will be under defining query methods. So we see some example here, find distinct people by last name or first name. Then we can ignore the case of the strings, find by last name, ignore case, etc. And here there is a list of all these like secret keywords. So it's find by, read by, search by, etc., delete by, and a list of the operators. We have greater than, ending with, is ending with. So there are multiple options for each operator. In our case, I think we use starting with, starts with, or is starting with. So find by name, starting with. Okay, this looks good. And we're just going to replace inside find all. We're going to replace this one, find by name, starting with. And let's just use account here. So now if we rebuild this thing, and need to find that postman in here. So yeah, we see that we only get account 2 now because they need to start with account. And the second method in which we can write queries is by providing using the query annotation. So let's call this second method search. And again, actually let's do this one with suffix string. And again, it's going to return an iterable of account. And we need to use this annotation called query. And yeah, this one from JPA. So in here, there is this language called JPQL, which is very similar to SQL, but not quite. There are some small differences. So we will do select A from account A, where a.name like, and here we'll do so we needed to end with the suffix, so like that. And we need colon for suffix. This will interpolate it with the arguments from here. So in here we just replace this one with, I think, yeah, it's called search, like that. And if we build this again, and we see that now we receive this these two objects instead of the second one. That's it for today. There are more videos on this channel about Spring Boot and Kotlin. If you want to support the channel, consider subscribing, like, comment, all that good stuff. Thanks for watching.